We are going to start with the Zener diode. So I gave you a very good small introduction about what is a Zener diode, and the Zener diode usually we talk about Zener diode when we are going to use reverse biased PN junction diode. So you have two types of breakdown in PN junction diode. One is called as normal breakdown, which is called as avalanche breakdown, or the when you're going to heavily dope the PN junction diode, you can get breakdown even at very small amount of voltages called as Zener breakdown. Okay, so we are going to study about the breakdown which is going to happen in Zener diode. So when you are going to reverse bias a PN junction diode in normal condition, the current through the junction will be very high and the power will be very high when you are going to apply a very high voltage across the junction. So when you are going to apply a very high voltage across the junction, it is going to damage your diode. But without damaging, if there is a mechanism by which I can ensure that a high current is flowing through the device, the diode is not getting damaged, that is going to be the condition for Zener breakdown. So when the diodes can be designed with adequate power dissipation capabilities to operate in breakdown region also, but the diode is still operating, it is not the diode is still operating, it is not broken down. So that is going to be the Zener diode. So Zener diode is going to be a very heavily doped diode than conventional PN junction diode. And because of this very heavy doping, what is the advantage? The breakdown voltage will be coming to less than 10 volt. I can achieve breakdown at less than 10 volt, and even after breakdown is going to happen, it is not going to affect your diode in any way. A constant when breakdown happens, a constant voltage is set up across the diode. The current will be increasing enormously, but the voltage will be same. Just like how you have in a forward bias, after a particular cut-in voltage, the voltage will be constant. Only the current is going to increase. Same way, after your Zener breakdown is going to happen, you can see the voltage almost remains constant, whereas the current is going to increase enormously. This voltage at which the current is going to increase enormously is called as Zener voltage or breakdown voltage of your Zener diode. So from the PI characteristic, it is found that in forward bias, it is going to be exactly same as PN junction diode. You until the cut-in voltage, it is going to be almost the current is very very less, and once the cut-in voltage is reached, the current will be increasing exponentially. In the reverse bias, the breakdown occurs at very low voltage. That depends on the doping. So how much you are going to dope, that determines your breakdown voltage VZ. If the diode is very heavily doped, then the depletion layer will be thin and breakdown occurs at a very low reverse bias voltage itself. So usually in forward bias only the depletion region will be very thin, right? But because of very heavy doping of your PN junction regions in the Zener diode, even in reverse bias also, if you apply the reverse bias, the depletion region will not increase that much. It will even be thinner at that point also. So what happens because of this thin depletion region, the carriers will cross the junction easily, leading to breakdown. And once breakdown happens, the current starts building up enormously unless you have some mechanism to control the current. Okay, the current increases enormously unless you are able to control it by some mechanism. Okay, so whereas in the lightly doped diode, it has a very high breakdown voltage. Conventional PN junction diodes, the breakdown voltage will be in the order of 1000 volts. Only when you apply a very large voltage, the carriers can cross the region and give reverse biased current. But when you are going to dope your diode heavily, this breakdown voltage just reduces from 1000 volts to just 10 volt or less than 10 volt, depending on the amount of doping you are going to do. So the breakdown voltage can be selected with the amount of doping. So the doping and breakdown voltage VZ are related. So the sharp increasing current under breakdown or due to the following mechanisms, it can be avalanche breakdown and Zener breakdown. So Zener breakdown happens here. Avalanche breakdown will happen somewhere later. The same characteristics you will have for avalanche breakdown also. So two breakdowns we have in any PN junction diode. One is in a conventional PN junction diode, you will be having avalanche breakdown. In a heavily doped PN junction diode, you will be having what is called as Zener